I became interested in photovoltaic hybrid power plants because I was curious about ways that renewable energy technologies could be integrated with existing infrastructure in a cost-efficient manner. I'm interested in industrial sectors and finding ways to invest in clean tech that are attractive and feasible to a company's bottom line. The way I see it, if you can convince companies that it's good for business to be good for the planet, then that's a win-win. So what are photovoltaic diesel hybrid power plants? Photovoltaic diesel hybrid power plants combine photovoltaics or solar panels and diesel generators or gensets to create electricity. In a photovoltaic system, PV modules turn sunlight into DC current. This is transformed into AC grid current by photovoltaic inverters. Because of the fluctuation in irradiation, the proportion of PV power that can be fed into a diesel grid, also known as the photovoltaic penetration, is normally about 20%. In order to achieve a higher share of photovoltaics and increase savings, smart communication is needed between the PVs and the gensets, enabling up to 60% penetration with maximum grid stability. If sudden load changes occur, the hybrid system reacts quickly. If necessary, photovoltaic power is throttled down to guarantee smooth genset operation and optimum grid stability. In the evenings, gensets take on more and more energy until the night when they take the entire load. If you use battery energy storage, you can save up to 10% more fuel. Photovoltaic diesel systems come in different flavors. Flavor 1 is battery storage. Because solar energy fluctuates both throughout the day and throughout the year, and because the generation capacity of the diesel gensets is limited to a certain range, it's often a viable option to include battery storage in order to optimize the solar's contribution to the overall electricity generation and minimize fuel usage. However, batteries are expensive and must be disposed of carefully, which can add extra considerations. A photovoltaic diesel system without energy storage has to spend at least 10% more on fuel than one with batteries, as the generators have to run through the night and during times of minimal irradiation. In some circumstances, this inefficiency can be offset by choosing to purchase electricity from the grid during those times. Flavor 2 is grid connected. There are several reasons why connecting a photovoltaic diesel hybrid power system to a power grid might not be feasible. Power grids have strict power quality requirements that are defined in standards or by supply authorities. Potential problems linked to the integration of PV systems to a local grid include voltage regulation, current supply, and harmonic distortion issues when the PV penetration level is very high. Also, in order to integrate DC current generated by photovoltaics into the AC grid, special inverters that meet rigorous quality controls are needed. These inverters add a lot to the end cost of the system and often render it unaffordable. Which brings us to the sweet spot. The best business case for photovoltaic diesel power plants is in remote or underserved regions, far from the grid. This is because in these environments the cost of diesel and transporting diesel is very high, and the savings are the most persuasive. There are many industries that operate in remote locations and need electricity, including mining, agriculture, water desalination, raw material processing, and tourism in remote areas. And now, for a little bit of history. The idea of combining solar panels with diesel power plants is nothing new. Way back in 1981, Popular Science wrote a story about hybrid plants, where solar collectors are combined with diesel generators. So, how come they're not commonplace? And why do I think they could make sense now? The main reason that I think that photovoltaic diesel power plants have the potential to become ubiquitous in remote or underserved areas with adequate sunshine is because it has recently become cost-efficient to integrate existing diesel genset infrastructure with photovoltaic systems. As you can see here, since 2000, the price of diesel has increased, while the cost of solar panels has dropped. At the same time, the demand for energy is rapidly increasing. I'm now going to compare the paradigms of infrastructure for grid-connected public PV diesel systems and industrial non-grid connected PV systems. I think that the public system would be for people living in remote areas and in the private for industries in remote areas. I think the costs would be more expensive for the public implementation, but the quality would be high for both. I think that new users would be the population of the remote area or the industries, I suppose. I think that the public implementation would be non-rivalrous and non-excludable, and that both would have the tapering effect and externalities. I think that the private implementation would have point-specific services, and that neither really involve free riders. Now it's time for a case study. One of the world's largest off-grid solar photovoltaic diesel projects has been successfully implemented at a copper and gold mine in Western Australia. It's providing up to 7 megawatts of power, which will ramp up to 10 megawatts during the summer months. The $40 million project incorporates more than 400 batteries and is expected to reduce carbon emissions by an estimated 12,000 tons a year. As one expert said, this is a clear example of renewables providing substantial, reliable results for one of Australia's largest industries.